Hey guys, today we are going to talk about a binary tree paths problem on LeetCode. The number is 257. The problem statement is actually pretty simple. So imagine you have a binary tree, something like this, where you have 1, 2, 3, and 4, let's say. Now the goal is to start from the root, from this root to each of the leaves and build on a path. So a path structure would look like one, this arrow and 3, and another path would be like 1, 2, 4, 1, 2, 5, etc. So we are constructing this path, and that path. Okay, now the first question to ask is, if I break down this tree into subtrees, let's say 2, 4, 5, if I apply my logic, whatever the logic I'm trying to build, if I apply my logic here, will that be enough information for me to solve the logic at this entire tree level? Meaning, if I build a path here, for example, a path like so, okay, can I use this information at this stage? Yeah, and as you can see, it's pretty evident, and you definitely can use this. So once you build this information here, like in an list of strings, something like that, you could use this, pass on this list back to 1 and append this result to 1, something like so. Okay, and because of this, it's basically a textbook recursion problem, right? So let's look at how the code will look like, and I'm just writing it the pseudocode here. So the actual code will be in the description below, and there is a GitHub link, so you can definitely check it out. I am not going to type out the code for you know See, the whole point of me not giving out the typing out the code as we are typing out is because, you know, not only writing the code but reading other people's code is also a very important skill, and I think I'm trying to inculcate that. Okay, so let's look at the pseudocode operation, right? So uh, let's ideally look at what they want. Okay, so the signature method basically is a public list of string. I'm just gonna represent as str, binary tree path and tree node. It's a root. Okay, so that's exactly what they want, right? So because you need to return a list, right? Doesn't matter what the root node is, you still return a list. So basically you can create a list. Oops, I'm so sorry. You can create a list and call it result here, and you just return result here, right? And if root is null, you basically return result right there. Else you need to do something here, that else part will come, right? So think of a simple helper function where you need to pass that root, right? Along with the root, we definitely have to construct the list. So let's try to write this helper function even before deciding what the signature would look like. So as a private method, I don't think, because we have considered putting the result as a global variable, you can just keep this method as a void method. And let's see, helper method, it definitely needs the tree node. you can call it node, comma. We'll see whether we'll need anything here or not. We can definitely check, otherwise we can correct it. So okay, now if root is equal to null, you just return, right? Then when will you need to construct a string, right? You need to construct this string. So when are you constructing this string? So you need to uh, pass this current value information down to its children, so that this path construction is facilitated, correct? Same thing is in here too. You need to pass this string, this information down to its children. So let's see if we can pass a string here, something like that, and string s. Okay, now if root is null, you're just returning it. But if now you need to s is equal to s dot you're concatenating the node dot value. Okay, see, I just said node dot value. If it is an integer, you need to do the parsing of the integer right here. But if it's just a character, you can just do that. If it's another string, you can just do that, right? But anyway, you need to take care of this use case. Now when would you, so you are concatenating the string, so at this point the root is 1, and as you go on here, the root is 1, and if you can start at an empty string here, for example, I'm just denoting this empty string as an underscore. Basically you put an empty string when you're writing it, but your string would be something like, let me choose the right pen. Your string would be something like just empty space, there's nothing here, plus if the root value is 1, you put 1, right? And you also need to concatenate s dot or you can just put something like here dot concatenate this arrow mark here. So you have this in your result right now. Now what happens, let's go right for a what happens if you go to the right? Because I said it's a recursion, you can actually go to the right. So you can just say helper and node dot right, and you pass whatever string you actually built here back to the function. Now let's see what will happen, right? So you are at this you are calling the right side piece of your tree, and as you are passing the right side piece of the tree, you are also passing this string which is 1, yeah, like that, right? You are passing that. Now the root is not null and you are still concatenating, so here you would concatenate 3 because that's the node value, but you're also concatenating this one. Okay, and again you go to the right, so the right is now, and if it is null, you're returning. So basically you are building this string, right? So you somehow have to handle an use case for this guy where you cannot add an extra value. But my other question, which is far more important question, is now I would ideally have something like helper node dot left comma s, right? So if you build this 1 3 let's say you handle this extra case where you don't have this, if you build this, when are you going to add this back to the result? Because in this, the paths, the result should look like this, right? So 1 3 1 2 4 and 1 2 5, how are you going to add it back? So you need to check if my left node and the right node are null. I mean, if you're already at a leaf, that's it. You can't construct the path anymore. At that stage, you need to add yourself back to the result. So now I can add a condition here. So I can say root dot left equals now and right equals now. Then you will say result dot add s. Okay. Now when you're adding s, before you add s, this concat statement, this concatenation, let me choose a different pen, let me choose a blue color or something like that. This statement has to come up here, and this concatenation of this extra arrow mark should happen only in the else condition of this guy. Okay, so yeah, I think that should definitely work. And yeah, I mean, try it out, and the link for this actual code is in the description, so you can totally check it out. And if you have any questions, just please leave me a comment. Okay, good luck guys.